Hello, lovely algebra students. Today we're going to talk about factoring special products. So get out your foldable and take some notes so that you can be all ready to go tomorrow for class. All right, so today we're talking about a difference of squares. Remember when we talked about multiplying binomials and we had this lovely formula? Well, now, again, we have a nice little formula here. When you have something that's a squared minus b squared, that's going to factor out to be a plus b times a minus b. And here are a couple of examples. The first thing that I'm always looking at is I'm looking at my first term and I'm thinking to myself, is this a perfect square? And I know that x squared is a perfect square because that's x times x. And I'm thinking, is 121 a perfect square? Well, I know that 121 is 11 times 11, so yes, this is a perfect square. Using my formula, again, I can factor this out to be, what's my a term? That's x. One's going to be plus, one's going to be minus, and I know that 121 is 11 times 11. So this factors out to be x plus 11 and x minus 11. Let's try the second example. Is x to the fourth a perfect square? Well, I know that that is x squared and x squared. I see my minus sign here, so I know that one's going to be plus and one's going to be minus. And now I'm thinking, can 25y to the sixth be factored? Is it a perfect square? Well, 25 is 5 times 5, so I know that that's right. And to get y to the sixth, that's y to the third times y to the third. So it factors out to x plus 5y cubed and x squared minus 5y cubed. Now looking down at 16p to the 8th minus 49q to the 6th, is 16 a perfect square? Well, I know that that is true, that this can be 4p to the 4th plus something, and 4p to the 4th minus something. 49, well, that's 7 times 7. Q to the 6th, well, that's going to be q cubed. So this is a really simple way to figure out if a difference of squares can in fact be factored. Here's Ms. Sokolowski.
Okay, guys, so now we are going to talk about a perfect square trinomial. So this will be the last flap on your foldable. And perfect square trinomial, we've seen these before back in the last chapter. So look at this first example. I'm going to determine if 9x squared minus 15x plus 64 is a perfect square trinomial. The way that we determine whether it is or not one of these special products is by doing this method right here. Let's draw your attention to this part of the screen where I take the square root of 9x squared. So you're thinking, what times what gives me 9x squared? Well, that's 3x. Okay, I take the square root of the last term, 4, which is 2. Okay, now what you do is you take 3x and 2 and multiply those together. You find the product of those two things. That is 6x, and then once you take the product, you double that, so I multiply it by 2, and I get 12x. If that answer right there is the same as your middle term, then you know that the trinomial is a perfect square trinomial. Now, this only works if the first term and the last term are both perfect squares, and then if the sum or if the product of the two multiplied together and then doubled gives you the middle term, then it's a perfect square. So let's try the example 9x squared minus 15x plus 64. I take the square root of 9x squared. Now all I'm doing here is testing to see if it is going to be a special product. This gives me 3x. I take the square root of 64, that's 8. I multiply those together, and that gives me 24x. And then I double it, so multiply by 2, that's 48x. 48x is not negative 15x. So this one right here would not be a perfect square trinomial. It is not a special product. Let's look at the second example. The square root of 81x squared is 9x. The square root of 25 is 5. So I find the product of those, multiply those together. That gives me 45x, and then I double that. So I multiply that times 2. 2 times 45x is 90x. which is in fact my middle term, so this is going to be a special product, a perfect square trinomial. Okay, so let's do these two examples. In pink, I have written what the perfect square trinomial is going to factor into. If it is a minus in the middle term here, then it's going to end up being a minus b and that amount squared, that quantity squared. If it's a plus in the middle, it's going to factor and have a plus in the middle of the quantity. So first of all, I see if this is a perfect square. I take the square root of 1x squared, that's 1x. The square root of 49 is 7. When I multiply those together, I get 7x, and when I double that, I get 2. 2 times 7x is 14x, which is my middle term, so yes, this is going to be a perfect square trinomial. Now, you guys will start recognizing these, but I'm showing you right now the way that you test it until you get to the point where you automatically see them. So this matches up with this first form right here, where I have a minus as my middle term. So I'm going to take that, and I'm going to write a minus b, and that quantity is going to be squared. Well, what's my a? My a is simply the x right here. See how it's in the same position as this a right here? So my answer is going to be x and then minus. Well, how do I get my b? My b right here is what this number is. 49 is 7 squared. So the b is the 7. Am I making sense here, Coach Wallace? You think they're following? Okay, hopefully so. So I have x minus 7, and I'm going to square that. So that's my answer, which, remember, guys, is the exact same thing as x minus 7 times x minus 7. If I FOIL that or multiply, I'm going to end up with the trinomial that I started with. Okay, so this is my answer. It's a special product. Okay, now that is the exact same thing you're going to get if you do the other method that we learned, but putting the 49 here, the negative 14 here, coming up with the two sides. See how we get the same exact answer, guys? So it's nothing new, crazy, hard that you need to go crazy about. It's just getting you to the point where you recognize these special products to make factoring easier. So this last example, I'm going to test to see if this is a special product. The square root of this is 7x. The square root of 100 is 10. When I multiply those together, I get 70x, and then I double that, I get 140x. So yes, this is going to be a special product. This example fits in with this form right here. Since I have a plus sign in the middle, my answer is going to have a plus sign in it. So I take a, my a in this problem is this right here. It's what quantity can I square to end up with 49x squared. That's 7x. So I have 7x at the beginning, and then a plus sign, and then the b is simply this, guys. It's what we got once we took the square root, and that's 10. And then that whole quantity is going to be squared. So that is the exact same answer as 7x plus 10 times 7x plus 10, which is the same thing that you would get if you did the t and the x that we've taught you. This is just recognizing that there are special products. All right, that's it. I'll see you guys tomorrow.